Let's talk about Aurora database a little bit. So it's also easy to create and do hands-on. It's not difficult at all, but you need to understand what are the different options behind so that you'll be able to answer in the exams. Okay. So what I'm going to do is I'm going to take you through the very basic. Remember, Aurora is the fully managed AWS only database, not available otherwise. Right? This is proprietary technology from AWS, unlike MySQL and Postgres. This is not a open source. So they are Postgres and MySQL compatible. What does that mean, compatible? Means if you are using a drivers as such, Aurora driver, sorry, a Postgres driver or MySQL driver via your applications to connect, and that drivers are going to work as it is. There's no changes, but the database is different. So this is the cloud optimized databases. They climb 5x different performance in a normal instance where you're running EC2 and MySQL on top of it, or MySQL and RDS. Okay, so it is 5 times better than that. For in case of Postgres, this is 3 times better than that. Okay, and the database auto scaling, you see, this is growing in every chunk of 10 GB. So first 10 GB is just gone up, then added another 10 GB. Then if that 20 GB gone, we'll add one more 10 GB. So this grows in chunks of 10 GB. And it can go up to 64 terabytes. Remember, Aurora can have up to 15 replicas, more than enough for any big databases, right? Where your RDs on MySQL can have up to only 5 replicas. So again, the replication process with Aurora is in sub 10 milliseconds, within 10 milliseconds replica, okay, which is really, really good. Next is, if this is failing at one availability zone, automatically the standby instance will be up and running before you know it. We'll not even know there is a failure, right? So this is instantaneous, right? That means that you will not even know this has happened. So it's high availability, it's achieved. That box is ticked. So again, Aurora, which costs you 20% more than your Odyssey instance, but you can see this is more efficient to work with. Okay, so these are the basic characteristics of Aurora database. So let's try to understand how they make this Aurora database highly available, for scaling up. At any point of time, if you take a single Aurora database, they use the 6 copies of your data, right? So they use 6 copies of your data across 3 availability zones. Okay. So what does that mean? At any time, they have a main instance and a replica and replica. In each availability zone, you'll have 1 plus 1, 2 copies of databases. Okay. Out of the 6 copies, 3 copies are for read only. Okay. And they are peer-to-peer replication. So they'll just replicate each other. Right? You don't have to worry about that. Most thing, the storage is actually kept in across hundreds of volumes. These are volumes, right? What are this box you're saying? These are volumes. So it's been done with across hundreds of volumes. And this is the only one master database which takes all the writes. Okay. In case if something failed in master, right? what will happen is one of the read replicas will become a master in the other region. Okay, that's an automatic failover. And you can also do a cross region application, very important. Right. Any questions? Please put me in the chat box. Let's talk about how this cluster is going to work, right? So if you are a client accessing this Aurora database, I see the requests of writes are normally come from here to here, then it goes to your main instance, right? Then you have something called auto scale read replicas, right? N number of read replicas. And this can be increased when there is a more demand, right? So again, on bottom, you have a storage, right? In storage, you have, from it's expanding from 10 GB, automatically expanding from 10 GB to 64 terabytes. So you don't have to worry about storage at all. Okay. So what I said, how does it work? The cluster normally uses something called two endpoints. One is a reader endpoint and another is a write endpoint. Okay, this is again, say first. The reader endpoint are pointing to multiple read replicas across availability zones, whereas in writer point endpoint will be pointing to the master instance. Okay, that's how the Aurora DB cluster works in the background. Okay. So a couple of quick features. I know it's going to take very few more minutes before we jump and create our first Aurora database over there. Okay. So what are the features we just seen? We just seen many options, but what are the major ones? Automatic failover, yes. Backup and recovery, it's well in RDS as well. We do have it here as well. Isolation security available here. Industry compliance, yes. Push button scaling, single button scaling, obviously yes, because it says right. It maintains the auto scaling. Number of read replicas, also the storage can be automatically increased. There's no downtime here where auto patching is applied during the maintenance window. And advanced monitoring, routine maintenance, backtrack. If something goes down, you can restore back to any point of time without having a backups. What does it mean by without using a backup? That means AWS does everything for you. So you can just restore to any point in time recovery. Let's talk about security. How secure is your Aurora database? Right. So the encryption technology used at the rest, right? So we can use a KMS, key management service, right? Use the encrypted data at rest. Automated backup, snapshot, replicas is also encrypted. When the data has been transferred, you can use a SSL, right? To do use a on-transit encryption or in-flight encryption. Okay, this is a shared security model where you are responsible within this instance, where they are responsible outside this instance, right? And as same as RDS, you can't do a SSL. We just talked about the auto scaling, right? Whenever you need, you can just automatically increase or decrease the number of, instances, right? As you could see, there are too many requests are coming in. You don't have to do anything. So the reader endpoint will understand there are too many requests, and then these two instances serving the read replica serving the reader endpoint based on the CPU utilization, it understands this is a lot of traffic coming in. It will actually add two more. Okay. When you add two more, your endpoint is expected. So the request which has been served by two read replicas will be now served by four read replicas and will be distributed evenly. So this is what we call replicas auto scaling, automatically scaling the replicas to handle the load. Not only that, you remember this reader endpoint, writer endpoint that we used to create? You can also use a custom endpoint used by only certain analytical queries or any certain system, right? So all your analytics, which will be sometime, intensive, right? So you can have create a very better one, and you can create that, you can run your analytical queries in a better machine. So you could see these are R3 large, and these analytical replicas are of size of R5 to X large. They are bigger machines to handle more rows, more analytical rows, right? So to do that, what we can do is we can enable a custom endpoint which will point to this particular two read replicas so that your analytical requirements will be met. All your analytical queries will be run on these two instances. So what do you mean by serverless? There's a server behind, but you won't be maintaining that. That's what we call a serverless, right? We call Lambda serverless. We call DynamoDB serverless. We also call Aurora serverless. It doesn't mean there's no server behind it. It just you won't be maintaining it. Okay, right? We have automated database clients initiation and auto scaling based on actual usage. Good for infrequent, intermittent, and unpredictable workloads, right? Especially unpredictable workloads. You don't need to worry about capacity. You pay per second, right? Means that you'll be a more cost effective of the time that you utilize. So high availability, we just talked about, right? In case something goes wrong, what will happen? This read write, right, is being promoted. So in case if one of it goes down, it will automatically fail over to the next one. You don't have to worry about it at all. Okay. So your one of your read replicas becomes your write nodes, and it's a global service. It's available across regions. So you can create cross-region replicas. If you want replicas to be served in multiple regions because the user base is across globe and different region, you can create something like a cross-region replicas, right? They are also used for a disaster recovery. At the same time, the request can be served from a different region for their users. Okay. So the default recommendation, as you could see, one primary region for read and write, and up to 5 secondary region for read-only database replication. Okay, so this is a recommendation. So let's talk about ML, machine learning. How does it come to Aurora? Right? In Aurora, you can integrate Aurora with your Comprehend and SageMaker services. So they are, SageMaker, right? And machine learning service. So using Comprehend and SageMaker, you can have a backend in Aurora, right? You can add ML-based prediction to your application via SQL, right? So right now, SageMaker and a Comprehend, right? For sentiment analysis and for any ML model, only these two services can be used with your Aurora machine learning. Aurora can be backup as a backend to your machine learning models. Okay. So where do I use sentiment analysis? Fraud detection, ads targeting, right? We can use Aurora with your machine learning services. Okay. Let's go back and create this Aurora. We are done, right? So we are done, almost done with the presentation. We will go and create a simple Aurora database now. Go to your dashboard. In the dashboard, you could see there is two create database buttons, right? Earlier, remember, we were using the bottom one. Now, go and use Amazon Aurora. Click on create database. So now you have chosen Amazon Aurora, right? It's the same option what you have seen it last time. So it'll be easier for me to explain that. But remember, you will not be choosing any database type, instance types, and all those things right here. Because by it has been fully provisioned by AWS, so you don't have to choose any of it. But still, I will come here and choose a standard create, then go to Aurora database this time. So MySQL is the other options, but I'm using a Aurora database. In the engine option, then I can see Aurora with MySQL compatibility or a Postgres compatibility. I will use the MySQL one, right? Because I used the MySQL instance earlier. So I'm going to use the same compatibility level as MySQL. The MySQL, there are two options for you. One, you provision the server, you decide what is going to be your server size. Same as RDS, right? There's no point of doing that. But what I love at is you go and choose the serverless, you take the entire maintenance and provisioning out of your hands. It's all fully automatic, right? If you go for a provision, you got to choose your engine version, you have to choose your things, all the things you have to choose, right? I'll show you that. I'm not going to use a provision version. If you use a provision, then you go and choose your production database and you choose your instance data types and everything similar to your RDS instance. There's nothing wrong, right? It's a very similar RDS on Aurora. Okay. And but if you use a serverless, you would see there's nothing else to do. No instance types, nothing. All you that's gone out of your hand, right? So let's go and create a serverless Aurora DB. So this is the version 5.6.10 is the version which I'm going to use. And usually give a database admin and password. Very similar to the RDS, only again here, give your password. And use a capacity setting, right? You need to choose what is the minimum maximum capacity, right? I can use up to 2 GB RAM into 122 GB RAM, right? This is called capacity units. 1 unit is equivalent to 2 GB RAM, right? So you use 1 unit to 64 unit that roughly stands into 122 GB RAM, right? You can also choose an additional configuration, right? So in fast compute capacity, if the limit is, if there's no activity, mean that it will be the compute will be saved and it will also save your additional cost. But I'll leave that one. So the RAM can be up to 2 GB to 122 GB. Connectivity, same options what we have seen before. You create your own subnet groups and VPC. You let the AWS to handle that, how many instances that they are going to deploy on that. And when you are using this subnet group, you have to give as many as possible. Example, if you have 6 availability zones, I would recommend creating 6 subnet groups. Don't go less than that. Okay. Sorry about that. Similarly, the databases, what you have given, right? The database options, what you've given can be also given here in this one. But otherwise, the only change would be here. You choose which compatibility you want and you choose your serverless option and give the all other details just like your RDS instance, like we have seen it earlier. Go ahead and create your database. As you could see, I'm creating a second database, and this time it is called database one, and it says a serverless instance. It's not a real instance. Okay, so I'm creating it in AP South 1 region, right? While it's creating it, it goes show the VPC and everything once it's all complete. Okay, and remember, we have a query editor where you can connect your Aurora databases from the console itself. You don't need a client tool to access them. Let's give it 2 minutes to load it while we look at the options of creating Aurora databases. Okay. Okay, so this is just creating database, right? So we want to see it and just refresh and see if this creation has been complete. Still happening. So I'll just go and look at the same option, what you have seen it in the audio sensors before, right? So I'm going to click on database one. It will take me through the details of this database, which is getting created. You could see this is my endpoint. This is the port which I'll be connecting 3306 for Aurora. And this is my VPC, subnet groups, right? And security groups. Monitoring using a CloudWatch, it gives you serverless database capacity count. It's a new one, which is not there in RDS, right? Secondly, CPU utilization. Third one, number of database connections. When I look at logs and event, remember, there's no events found because it's still being created, but you will see the same option what you've seen before. And configuration, you'll see this is the Aurora configuration, right? There's no parameter group comes in place here, but here have default parameter group for Aurora 5.6. You can create it. And I'm sorry. So this is a default group for Aurora, not the MySQL one, right? The one what we created earlier for MySQL. At this time, we'll be creating one for Aurora, right? Your maintenance backups. What is your automated backup? Enabled every 1 day, right? You can also take a manual snapshot out of this. Let's go back and see. See, this is a successfully created database one. What is my connection detail? These are my connection detail. This is my endpoint. This is the admin, and this is the password for the admin, right? Just close this. I'm going to use this query editor. You see on the left side, you go and choose the query editor. In the query editor, you can connect to the database instance, especially to the Aurora one, not to all of it, right? You can choose your Aurora database, which is database one, and use a username or connect with the secret manager ARN. What is the secret manager ARN? You have something called a secret manager where you can store the username and password, and you'll get the link. And if you just use the link, you don't have to enter this manually. But here, I'm going to use this one admin test 1, 2, 3, 4. This is my username password. Okay, sorry, just clicked on something else. While you do that, so click on database one again. Use your database credential. So mine is like admin test 1, 2, 3, 4. Then leave the default options on. So click on connect to database. It says your data API is not enabled, right? I have to modify the database to enable the data API because all the query editor doesn't directly connect. Rather, they will use the APIs available. So it was asking you to modify the data API option to enable it. So I'm going to click on modify database, right? Click on modify here. Look at the option down, which will help me to choose the data API enable. So just come, let's see, you see this, right? The connectivity. Now you see an option called web service data API. You have to enable it in order to query using your query editor. So I'm enabling this one. It was disabled like this. Enabling this checkbox for data API, right? I'm coming when modifying the database. No other changes, but I want to apply that immediately. So we can apply the same changes during a maintenance window, which will be later today, but I want to apply that immediately and go and click on modify cluster. Okay. So enable it, right? So let's go back and try the query editor option. Go back. I choose the database. Use your admin credential. I just given it. Click on connect to database. That's it, right? As you could see, I have connected to the database. So I can just run this particular one. You can see how many databases are available by default, right? So it just returns what are the default tables available. The table schema is information schema, right? This is about your system tables, right? It's available. I can create and save queries also for it, but it works like this, works like your exact SQL client. Any SQL client, which DB database client, which you'll connect and request data from. Okay. So Aurora database allows you to connect the query. So the security groups determines who can connect from where. And you have different option groups, that is for the RDS. You have subnet groups, which decides oh, how come your availability percent on all those things. And you can also create database for SQL Server and etc. I'll quickly show you how to create RDS SQL Server and how much difference it makes when you try to do it, right? So here in RDS database, click on create database. When I do that, choose SQL Server this time. Remember, I'm not choosing MySQL, I'm choosing SQL Server. It provides a lot of option. If I use a SQL Express, or I can choose the Enterprise Edition, right? I'm not going to create it. I'm just giving you an option to show what are the ways to say. I choose version, which is 15 is my latest. As you could see clearly, the license is included, means it's going to be costing more than your MySQL. In case of a MySQL, there's no licensing cost involved. There's no licensing cost. In terms of Microsoft SQL, MS SQL, you will see there's a licensing cost involved in it. Same applicable to your Oracle instances as well. But here you have option, right? License, bring your own license. Means you have to keep a license copy for yourself. You have to purchase one for yourself. Okay. But if you choose this enterprise edition, right, the enterprise edition comes with bring your own licenses. You're supposed to give the license key yourself. But in terms of Oracle Standard Edition 2, right, you can keep a license included model. So that's the only difference when you're working with different databases. Okay. So MySQL Server, remember, it comes with license included. But in Oracle, if you choose the Enterprise Edition, then the license is something that you need to procure and keep it ready. Okay. I hope this is clear. All of the changes are going to be same, right? There's nothing, no major changes here. Okay. So look at this option, and it's going to cost you about 2000 USD per month. Okay, when you do that, right? When I choose this one, for example, SQL Server, come at the end of it, and it's going to cost you about 44 USDs, right? This is based on the settings choose that you already chose. Okay, you can calculate and utilize how much cost is going to take, and accordingly, you can define your databases. So at good part of any demos, we have to go and clean up our resources that we create, right? As a best practice, and so it will be built later. So right now, I have created two databases. I'm going to delete them back so that it will not be built. So this is the end of the demo here. I'll go and click on database one. I go to actions, click on delete. This databases doesn't have a, these databases are enabled for delete production. So I can't even delete from here until I go and modify this. I click on modify, and you see an option called delete production. You have to disable that. Then you have to come back and delete the databases. Okay. So let me just see those options somewhere down here. Here you see deletion production, right? If you enable this option, nobody can delete these databases via programmatically, and nobody can delete it from the console itself. So I disable it. I'll continue on modify so that I can delete it. Oh my God, I have to apply that immediately. So let me just do one more time. What I have chosen is to update this during the maintenance window. It's not going to help for me to delete right now. So enable this protection. So disable this delete protection. Continue. I want to apply this immediately. Okay. The second one, for maybe for this one as well, click on modify. Look for the option delete production. So this is by default, disable. So obviously I can go and delete this database. Okay. Go to actions, delete. I don't want to find a snapshot. I'm good. So I'm going to type like a delete me, and I'll let it delete. Okay. I just started deleting this one. Can you say the first one, the Aurora database also I'm going to delete. Click on delete. I don't want a final snapshot to be taken, and I acknowledge there is a risk of not having a final database snapshot, because if you don't have final snapshot, you will lose the changes. You will not have any data in case if you want to restore back. I'm okay since it's a demo. Okay. I started deleting it, and you can see both will change into deleting status now. All right. So that's it for today. For probably from next class, we'll start looking into something called Elasticache. Right? This Elasticache is the another database option provided by AWS. We'll start looking into Elasticache and others from the next class. Okay. So I appreciate your time being here. Thank you so much for joining the session today. Have a good day ahead. Thank you.